Good day, friends. My name is Nelson, and this is Nelly Mark's concept. Nelly Mark's concept is all about mathematics. Mathematics is made easy here. At Nelly Mark's concept, we solve questions from examination bodies like JAMB, WAEC, NECO, NMC, PAMO, IMO, and so on. Today, we are going to be solving JAMB questions on the topic binary operations. Okay, the topic is binary operations, and we will focus on JAMB questions from this very topic. Before we proceed, if you have not subscribed to this beautiful channel, please can you do so? All right. Encourage us by subscribing. Also hit the notification bell so that anytime a new video is uploaded, you will get to know about the video. Don't also forget to like, share the video, drop a comment also. It's a way of getting feedback. All right, thank you so much. Let us proceed to the lesson of the day. Okay, let's look at the outline. We are going to look at the definition of binary operations, followed by problem solving. We are going to solve a number of JAMB questions on this very topic. All right, let's look at the definition. Definition. When an operation is performed on any two elements of a set based on a well-defined rule to return one element, such operation is called a binary operation. Let's read further. The operation can be denoted by star, a triangular shape, a rectangular shape, and so on. The binary operation, say star, is a rule which could suggest addition, subtraction, multiplication, division, exponential, and so on. It seems the English is too much, but I'm going to make it very simple. I'm going to break it down so that you will understand the concept very well. Okay. All right. If you add two numbers, let's say 2 and 3, to get 5, what you have just done is binary operation. It is that simple. It has to do with combination of two elements of a set to get a value. Okay, when you are combining 3 elements or more, it is no more binary operation. You know, from the name binary. Okay, so it deals with what? 2. Bi has to do with what? 2. So 2 plus 3 equal to 5 is a binary operation. The first element is 2, as you can see. The second element is 3. So 2 plus 3 returns 5. Okay. Then in mathematics, whatever that is inside bracket is regarded as a collection. Okay. So even though you are seeing 3 numbers, 2, 3, and 7, you may think it is not a binary operation. It is still a binary operation. Okay, because the bracket is regarded as one thing, as a unit or as a collection. All right, and you know, in mathematics, priority is given to an expression inside a bracket. So whatever that is inside a bracket is treated first. All right, so we have 2 plus 3 in a bracket. So we are going to perform a binary operation on this expression inside bracket. Then we will now multiply by 7. So this is still within the domain of binary operation. So 2 is the first element, 3 is the second element. So 2 plus 3 is 5. That's a binary operation. Now we are going to perform another binary operation. The result of 2 plus 3 is 5. So that 5 times 7 is 35, which is also a binary operation. So a binary operation is just an operation that gives you a rule or that gives you a formula which you can use to perform operation or to perform arithmetic operation on two elements of a set. Okay, let's look at this third one. 10 minus 3 is equal to 7. You see, 10 is an element of a set, 3 is an element of a set. Let's just say integer. Okay, 10 is an integer, 3 is an integer. So 10 minus 3 or plus 10 minus 3, they are all integers. So plus 10 minus 3 returns 7. So these are examples of binary operation. 12 divided by 4 returns 3. It's a binary operation. Also, 2 raised to the power of 3 is a binary operation, exponential. Okay, so 2 is the first element, 3 is the second element. So 2 raised to the power of 3 is what? 8. Okay, then 8 minus 7 returns 1. So these are examples of binary operation. So with this, I believe you have an idea of what a binary operation is all about. Alright, but there is a standard way questions are being asked on binary operation. So these are some of the questions we shall be solving in today's lesson. And as I said earlier, most of these questions are JAMB questions. So if you are preparing for JAMB, this lesson is so important for you. So you have to stop by, take your time, pick a pen, pick a paper, sit down and listen to this lesson. Take down notes as well. The lesson will really benefit you a lot. Okay, let's look at example 1. Okay, the binary operation star is defined on the set of integers such that P operated on Q is equal to PQ plus P minus Q. Now find 2 operated on open bracket, 3 operated on 4, then close your bracket. You can as well read it this way. P star Q is equal to PQ plus P minus Q. Then find 2 star 3 star 4. We're going to look at the solution to know which of the options is the correct one. Alright, now the most important thing to note here is the formula. For each question on binary operation, there is always a unique formula, or there is always a unique rule. There is a rule to obey or rule to apply. Alright, so that formula will guide you in solving, or in combining any other 2 elements of the particular set under consideration. Alright, so we have P operated on Q is equals to PQ plus P minus Q. Now let me explain what is happening here. Now the function of this star, this operation, the function is this. It is telling us to multiply the first element, which is P, by the second element, which is Q, PQ. Then we add the first element. Then finally, we subtract the second element. So this is what this operation is suggesting. Each formula or each operation is suggestive. Okay, so this is simply what we are being prompted to do here. Now, we are being asked to use this formula to combine 2 operated on open bracket, 3 operated on 4, and close your bracket. So, and as you know, in mathematics, whatever that is inside bracket is being considered first. So we're going to perform a binary operation on 3 and 4 based on this rule. Okay, we'll do that first, then we'll take up the next. Okay, now our P is 3, as you can see, then our Q is 4. So don't just see 3 as 3. Most times see it as what? The first element. It will be better, it will not confuse you. So 3 is the first element, which is like P. Then 4 is the second element, which is like Q. And we are going to combine them in this manner. PQ plus P minus Q. Okay, let us proceed. Okay, so 2 operated on open bracket, 3 operated on 4 is equal to 2 star. Of course, our P is 3 and our Q is 4. So at this point, we'll have 3 times 4, that is PQ, okay, plus 3, which is P, then minus 4, which is Q. So 3 times 4 is 12, then bring plus 3, bring minus 4, and that gives us 2 operated on 11. As you can see, very simple. Now, our P is 2 and our Q is 11. That is what we have now. Because anywhere you see star, apply that formula PQ plus P minus Q. That is what star is suggesting in this particular question. All right. So we are going to apply the rule or the formula carefully. So our PQ is what? 2 times 11, then plus P, which is plus 2. P is the first element. Then minus 11 being the second element in this particular binary operation. So we have 24 minus 11, and that gives us 13. Okay, 13 is the answer. I think it's very, very simple. All right, you can pause the video and take down notes for yourself. A binary operation on real numbers is defined by x operated on y is equals to xy plus x plus y. For 2 real numbers x and y, find the value of 3 operated on minus 2 over 3. And these are the options. Option A, minus half. Option B, 1/3. Option C, minus 1. Option D, 2. As usual, let's look at the solution to get the correct answer. Okay, don't forget the rule. As I said earlier, the most important thing here is the rule. I said that for every question, there's always a formula. So that makes it so easy for you. So you don't have to cram any formula in this topic, okay? The formula will always be given to you. And you just have to apply the formula carefully, all right? Or follow the prompting from the formula carefully, and you always get the correct answer. All right. Now we are given this binary operation x on y equals to xy plus x plus y. Now we are being asked to use this formula to combine 3 and minus 2 over 3. Right? Now, let me ask you a question. What is our first element? 3, right? And our second element is what? Minus 2 over 3. Okay, let's combine them. So if we combine 3 and minus 2 over 3 based on this operation or based on this rule, then we'll have 3 into minus 2 over 3, that is xy, plus 3, which is x, plus minus 2 over 3, which is y. So let's do the arithmetic. These 3 will cancel 3, so we'll have minus 2, then plus 3, then we'll bring down our minus 2 upon 3. Minus 2 plus 3 is what? 1. We still have minus 2 over 3. Then we'll take the LCM. 3 times 1 is 3. 3 minus 2 is 1. So we have 1/3. Okay, 1 over 3 is the value that is returned when 3 and minus 2 over 3 are combined based on this formula. That is very, very simple enough. If x operated on y is equals to x plus y squared, find the value of 2 operated on 3 in bracket, then operated on 5. Option A, 36, option B, 25, option C, 11, option D, 55. Let's look at the solution. Yes, we have to write down the given formula. Okay, x and y are being combined in this manner, x plus y squared. Okay, you write the first element, then you add the square of the second element. So if this is a working formula, how do we combine 2 operated on 3 in a bracket, then operated on 5? Of course, we have to work on 2 star 3 first before we now use the result to work on star 5, right? Okay. Yes, as usual, we are going to consider the bracket first, all right? So our formula is x star y equals to x plus y squared. So considering the bracket first, our x is 2, then our y is what? 3. So we have x plus y squared, which is 2 plus 3 squared. Then we repeat our star 5. Okay, that will be waiting for us until we are done with the content of the bracket. All right? So we're going to have 3 squared is 9. So 9 plus 2 is 11. Now we have 11 star 5. 11 star 5. So our first element now is 11. And our second element is what? 5. So, and the formula is x star y is equals to x plus y squared. So we're going to have 11 plus 5 squared, and that returns 36. So the answer to that question is 36. Yeah, you can take down note. Okay. Let's look at the fourth question. A binary operation star on the set of rational numbers is defined as x operated on y is equals to x squared minus y squared all over 2xy. Find the value of minus 5 operated on 3. So x star y equals to x squared minus y squared all over 2xy is our working formula. All right? And we are using this working formula to perform a binary operation on minus 5 and 3. Yes. So minus 5 is our first element. 3 is our second element. And we are taking the square of the first element. Then we subtract the square of the second element. We divide the result by 2 times the first element times the second element. It is just that simple. So here we have minus 5 all squared minus 3 squared all over 2 into minus 5 times 3. Okay, so minus 5 squared is 25, then 3 squared is 9. So we have 25 minus 9 as our numerator, then divided by minus 5 times 3 is minus 15. So we come down, 25 minus 9 is 16. Then 2 times minus 15 is minus 30. So here we have minus 16 over 30. And this expression is not in its simplest form. So there is need we simplify further. So 2 can go into 16 8 times. 2 can as well go into 30 15 times. So this is much more simplified. I think it's already in its simplest form. Yeah, it's a common fraction. So the answer is what? Minus 8 over 15. That's the answer to question 4. All right. I hope it's simple enough. All right. Let's look at the fifth example. A binary operation star is defined by A operated on B is equals to A raised to power of B. If A operated on 2 is equal to 2 minus A, find the possible values of A. Okay, this is a question given to us. And as I said earlier, one good thing about this topic is that for every question, a formula is always given to you. So all you just have to do is to carefully apply the formula. Follow the promptings from the formula. Okay? Because every formula or every rule always suggests or always tells you what to do. And you are only combining 2 elements at a time. Okay? At a particular time, you are not going to combine more than 2 elements. You are only performing operation on only 2 elements of a set, of the set under consideration. All right. So look at the options for this question. Option A is 1 or minus 1. Option B, 1 or 2. 2 or minus 2, and a minus 2. All right. Let's look at the solution. So what we will write out is the formula. I call it working formula. All right, it's the working formula. So we have A star B equals to A raised to the power of B. Don't just mind my choice of word. I can choose to call it A operated on B, or I can say A star B. Okay, I think they all just mean the same expression. So A star 2 means A power 2. Why? Our first element is A. Second element is what? 2. So it is what? A squared. And from the question, we are given that A star 2 is 2 minus A. From the question, you can um, go back and check again. All right. So A star 2 is already given to us as what? 2 minus A. And our A star 2 is what? A squared, according to the rule of this binary operation. Right now, we are left to solve this. A squared is equals to 2 minus A. Is that clear? We are left to solve A squared is equals to what? 2 minus A. And this resembles a quadratic equation. But what we can see here is that this equation is not in standard form. I hope you know when your quadratic equation is in standard form. That is when it is in the form ax squared plus bx plus c equal to 0. So we are going to express this quadratic equation in standard form. Let's see how it goes. So we are going to bring 2 and minus a to the left hand side, and that gives us a squared plus a. You know, when minus a comes to the left hand side, it becomes plus a. And when 2 comes to the left hand side or crosses to the left hand side, it becomes minus 2. So we now have our quadratic equation in standard form. So let's solve. As you can see, this quadratic equation is factorizable if we are given a squared plus a minus 2 equal to 0. Then this plus a can be expressed as plus 2a minus a. You know, if we add 2a and minus a together, we'll get a. Okay, and when we multiply 2a and minus a, we'll have minus 2a squared. So that's the whole idea of factorization. It's something I believe most of you are familiar with. All right. So we group a squared plus 2a. As you can see, a is common between a squared and 2a. So we factor out a that is common. Then minus a and minus 2. Minus 1 is common. So we factor out minus 1. Then you have a plus 2 in the bracket. So since we have a plus 2, we pick 1. Then we group this way. A minus 1 into a plus 2 equal to 0. Okay. If two expressions multiply themselves to return 0, it means either of them is 0. Yes, it's a known fact in mathematics. Okay, if two expressions multiply themselves and the answer is 0, it means either the first expression is 0 or the second expression is 0. So it is that a minus 1. It is either a minus 1 is 0, then a equals to 1, or a plus 2 is 0, then a is equals to minus 2. So the possible values of a is equals to what? 1 and minus 2. Okay, 1 and what? Minus 2 are the possible values of a. Alright, so that is that. I think it is clear. Okay, we have solved 5 solid examples on binary operations. Now, I want to carry out a summative assessment. Okay, I want you to solve some questions, about 3 questions, okay, to know whether you actually understood what you have been taught. So you are going to check yourself. Yes, check yourself. Check your understanding of this lesson. Five examples have been solved. So I'm going to give you three questions to solve. And they are all simple. All right. So this is number one. This is number two. The second question. Okay. And this is number three, the third question. So solve these questions, okay, and do well to go to the comment section and drop your answers there. I will go through, right? Drop your answers there. And if there is any of them you cannot solve, still leave a comment. All right, I will always attend to your comment. And if you have question, yes, go to the comment section, drop your question. All right, always feel free to drop your question. And if you have any question on this topic that you could not solve, you can as well, drop it on the comment section. I will always attend to it. Thank you so much for your time. We are going to meet again in the next lesson. Kindly subscribe.